direct here, put that in. Okay, great, thanks. You can start.
Okay, hi everybody. I am Federico Capuano. I'm core developer of the OpenWSP project. I work for a consortium, you can hear? Cineca Consortium, which is an Italian no-profit consortium that offers services to Italian institutions, and my job is public Wi-Fi. I'm also a contributor of Linux, an Italian wireless community network, and I'm here to present you the new OpenWSP controller. It's an application with which you can manage OpenWRT or LEDE devices. You can use it to implement a mesh network or public Wi-Fi or any network you can implement with OpenWRT. Because I have a very short time, less than 15 minutes, I prepared a screencast because I wanted to do a demonstration. So I will play the video and explain you the main features, because I think this is the best way to give you an idea of what you can do with this software. Okay, you see here, this is the Django admin interface. You have three main objects, which are configurations, which represents configurations of devices. Templates are bits of configurations that are shared among devices. VPN servers are configurations of VPNs that you can use. It's optional to automate VPN connections from clients. And certification authorities and certificates are used for a specific use case of this automation of VPN certificates. So let's go ahead. Here I'm creating a template and I give it a name. Just to start with something easy, I'm defining a time zone, because I know that all my devices will use the same time zone, so I define it just once, and I give it the most appropriate time zone for me, which is Rome. And then I remove the other fields because I don't need them, because those fields are usually used locally on each device, and this is a template. It will be shared and used by all the devices. Here I show the advanced mode, which you can edit the configuration in a JSON format. It's called NetJSON, look it up. It's an attempt to standardize some configuration stuff related to the networking. So I give it a description, a descriptive name, and I save it. And this is it. I'm assuming you're using OpenWRT. I also flag it as enabled by default, which will make it activated by default on each device that will register to the system. I save, and I go ahead. I add a new template. This time slightly more advanced. I want to add my SSH key into all devices so I can log in and manage them without supplying a password. So here I show how to do that. You add a file. You have to, it's a little bit of an advanced system. You have to know what you're doing. If you know what you're doing, it's really powerful, but it's not yet ready for users that have no knowledge of networking. So I added the SSH key, and now I do something slightly more complicated. Let's say I know many devices will have 2 gigahertz Wi-Fi access points, Wi-Fi access point interface, and I do that. I create a template for this use case. Here I'm probably talking in the video. I went too fast. Here it is. I give it the name 2 gigahertz Wi-Fi access point. I enabled by default. I start by creating the radio. So in OpenWRT, you have to define the radio, the configuration of the radio, like what power, what channel, and then you define the Wi-Fi interface, the SSID and this kind of stuff. So here I'm adding the radio. You can see that I mostly use the defaults. I can leave some fields empty. And the channel, I leave it auto, so Linux will automatically select the channel it finds best. I put a low power for the radio, I select my country, and then I'm ready. And I proceed with adding the interface. And you can see that there are quite many options. Here I select the wireless interface. There is also bridge and normal network interface. I leave all these fields empty. I have to manually, unfortunately, still type radio 0 in that red field. Here I'm showing the options you have, but now we use access points. You also have mesh, you have ad hoc, station. I give it an SSID. Here I type in FOSDEM test, OpenWSP2. These fields are slightly more advanced, and we don't care about them now. And I leave the network with no encryption. And the radio is there, done already. Just to check that the result is good, if you have experience with OpenWRT, you can check the preview, and it will show you the generated configuration. So if you have experience with this, it's called UCI, you can check that everything is correct. That's actually what will be installed on the system. We have package network and package wireless. And we are ready to go. And we save it. So now I show you how to create a configuration. You usually won't need to do this manually because devices, if you are managing many devices, you compile a firmware that will automatically register to the application. And so you won't need to do this. It will be mostly automatic if you work well with the templates. But here I'm doing it manually, inserting a dummy MAC address just for example purposes. You see that now scrolling down, those are the templates that are automatically selected. We just created in the video. And now if you see that the configuration is empty, but the templates are there. And if you hit preview, you will see the final resulting configuration in text plain format. You see the time zone is what we set there, which in OpenWRT is a bit strange. And then you see what we created before and SSH key. We save it. And once you save it, you can also download the generated configuration, which is at RGZ, which contains what you usually put on OpenWRT. On OpenWRT, this will be added to the existing configuration in a smart way. So you can remove it, update it, but not mess with the existing configuration. So now I went on a different system, and I'm showing you how a device will automatically register to the system. So this is OpenWRT, the web interface. On the new device, I just have to set up the LAN interface so it can connect to the internet, because the controller now is hosted on the internet, but you can also host it locally on a local area network. It's up to you, the setup, really. So here I selected the DHCP, and the network reconfigures, and I have to log in again. This is OpenWRT. It's a Linux distribution for routers and wireless networks, anything. It's also used for IoT. And now I'll show that there is a daemon that tries to contact the OpenWSP2 controller. Here I'm logging in again after having reconfigured the access point. And here you see, maybe you cannot read, but it says new device registered successfully as the MAC address and the ID. And then it says configuration controller has changed, testing configuration. So the daemon also tests that the configuration works. If it doesn't work, it rolls back. 10 minutes left? I thought less, actually. That's good. So Here I show you that the daemon now will have configured itself, the ID and its key. This is the stuff it uses to download the configuration from the controller. And you see the host name here changed. It automatically set its MAC address. So now you can take this MAC address, go in the list of the devices, you update and you find it there, and you give it a better name, of course. Here I call it FOSDEM test. And you see the default templates are automatically selected, so it has already downloaded them. But I also add the 2 gigahertz Wi-Fi, and you can see you can also override or add more stuff in the single device configuration. Here, just this is something you could do for maintenance purpose. Add the descriptions of here I put maintainer as myself, and I add a note test device. Usually before saving, I always check the configuration. You can see there's quite a lot of stuff from the default templates, but this is automatic. I didn't have to do anything. Once you define the templates, adding new devices is really easy. So now it's saved, and here I open the log grid, interactive mode again, to show what is performing behind the scenes. And you see it was testing the configuration. It's reloading everything. You see quite a lot of logs from all the components of OpenWRT. And the configuration test succeeded, and now it's configured. You see the WLAN 0 interface is brought up, and the SSID of the free Wi-Fi service, which is bridged. The Wi-Fi is bridged with a layer 2 VPN here, and the layer 2 VPN is correctly running. Here I show it with a command. So I got all this stuff done for me automatically in no time. It's pretty powerful. It's still not for users that don't know much about networking, but I really want to make it easier. But now we're getting more users. We're getting a lot of interest from emerging economies, especially India and South America. It's quite interesting. But we use this software also a lot in Italy. Italian institutions use it for offering public Wi-Fi, the old version. But some institutions are starting to picking this up. For example, the University of Urbino is using it to manage its own Wi-Fi. They also use it to provide EduROM to the students. And okay, how much time do I have left?
7 minutes.
7 minutes.
Really? No.
No?
2 minutes. Really?
2 minutes. Okay, so time for questions. There's no time.
When you say you validate the configuration, is by only syntax, or are you trying to test if the user that configured the channel that is not supported by the radio?
You used a term validation. Validation is the validation of the schema before you save. Then there is the daemon tests the configuration. There is a default test, and the default test is that the device is able to contact the controller again after the new configuration, but you can define your own test.
Yes, but if it's wireless, you are configuring, for example, the radio,
Mm-hmm.
and you test if the syntax is correct, and you test if it got enabled successfully, or you want to...
No. The default test is very simple. The default test is I can contact the controller again.
But that is internet.
It's not necessary on the internet. The important thing is that you can reach the device. If something is wrong, you can fix it manually, or you can define your own test.
So how do you know that the Wi-Fi is correctly configured?
It depends on you, on your use case. I cannot foresee all the use cases of the people that will use it, so you will have to define your own test in the firmware.
Okay. So what
It's a hard problem.
using to communicate between your controller and
HTTPS.
why not RPCD that's already
It was
implemented?
easier to implement. It's just me working on this. And also I do it in my free time, so.